Hi all. In this video we're going to go ahead and do the same thing we've done in the last two, practice calculating probabilities for a normally distributed variable. This time using GeoGebra, which is a graphing calculator available for free online. And first thing I need to do is make some adjustments because I was not thinking clearly when I wrote this out. So the very first thing you should do is remember to draw a labeled picture. Right, we know we should draw the labeled normal curve, mean in the middle, standard deviations in either direction, mark the boundaries of interest, shade in the area you're trying to find. Once your picture is set up and your probability statement is set up, you're going to go to GeoGebra and you're going to use the normal function for each of the given x values. And what this normal GeoGebra function does is it takes in the mean and standard deviation of your variable, takes in a boundary value, and it spits out the area to the left of that boundary value. So this one, we are going to have to use that 1 minus trick. We are going to have to go back and use the picture to determine the area or probability of interest. If we want a right tail or a middle tail area in the middle. Sorry, I can't think straight today. We're going to do some examples and I'm going to show you what that looks like. I'm also going to show you a neat function on GeoGebra that the other calculators don't do. But let's look at our example. So it says the average credit card debt for college seniors is $32.62. If the debt is normally distributed with a standard deviation of 1100, find these probabilities. First one says a randomly selected senior has less than 1,000 in credit card debt. So I'm going to come in and label this first picture. I'm going to do this sideways because it's going to get messy pretty quick. So 32.36 is our mean. And then we're adding 1100. So 43.36, 54.36, 65.36. In the other direction, 21.36. 1036, and then 1036 minus 110, negative 64. Okay, so it says find probability randomly selected senior has less than 1,000 in credit card debt. So I come to my picture. 1,000 is a little bit outside of 2 standard deviations, and less than is to the left, so I want that area there. Which fortunately for me is great. I know that normal in GeoGebra does areas to the left. So this is going to be normal, and in GeoGebra it asks for the mean and standard deviation first. So 32.62, 1100, and then it asks for our boundary value, which is 1,000. So let's go ahead and enter that in GeoGebra. So I'm going to pull GeoGebra up here, make this a little wider, and I'm just going to enter that here. So normal, you'll notice as I start typing it pops up, and it'll remind you what goes in that function. So we want 32.62, 1100, 1000, and we get 0.0198 rounded. So a little bit less than 2%, and that makes sense because I know just outside of 2 standard deviations is a little bit more than 2%, and I want less than that full area. So that's perfect. Next one, same picture, so I'm not going to relabel. And it says randomly selected senior has more than 5,000 in credit card debt. So PX is greater than 5,000. because in the picture, 5,000 is between 1 and 2, so right here. And greater than is to the right, I'm going to have to use the complement trick. I'm going to do 1 minus the area the calculator spits out. So 1 minus my normal function call. 3262, 1100, 5000. So in GeoGebra, oh my gosh, I just hit all that. So here's my picture. Sorry about that. I'm a little brain dead. X is greater than 5,000. 1 minus the normal because we want the area here, and the calculator is finding the area here. And I know together they make up an area of 1. If I go back to GeoGebra, you'll notice it gives me a bigger area. I can go to the front and do 1 minus, and it'll fix that. And it gives me 0.057, and then 0.5 would round up to 1. And I know that this is 95. Ooh, that got a little out of hand there, didn't it? I know that this here is 95. So this chunk being a little bit more than 5% isn't shocking at all. That is a reasonable value. And I guess I should show you my picture. Try that again. I know this is 95. So this chunk being 5 is not surprising. Okay, last one and then the neat trick. So this one says a randomly selected senior has between 3,000 and 4,000 in credit card debt. So if I scroll up to where labeled, 3,000 is going to be pretty close to the mean, but a little bit less than. And then 4,000 is going to be a little bit less than that 1 standard deviation away. I want this area here. So probability that I'm between 3,000 and 4,000. And to do that, I know from our table video, I'm going to do the bigger area to the left minus the smaller area to the left. So I'm going to do the normal function call for 4,000 first. 32, 62, 1100, 4,000. And then I'm going to subtract from it the normal function call for the smaller value, the 3,000. So let's go ahead and pull up GeoGebra and try that, and then I'll show you a neat little shortcut. So normal, 3262, 1100, 4,000 minus, whoops, normal, 3262, 1100, 3,000. Oh, I forgot an L. Thank you for telling me that. Oh, I made a typo and now it's being funny. Let's try that again. And we get 0.34, and then 299 is going to round up to 30. And again, that makes sense if I go back to my picture. That makes sense because I know this is 68, and I can clearly see the area I shaded is almost half of that. And I'm getting about half of that. Okay, now the really nice part. GeoGebra does something the other calculators don't. If you go up here where next to Calculator Suite, you'll notice there's options, and one of them is probability. And it has a list of all of the distributions we're going to be using this year. And you can come in here and we're going to do an interval for this last problem. We want a middle area. Our mean was 3262. Our standard deviation was 1100, and I want between 3000 and 4000. And you will notice that it gives me the exact value we calculated the other way, and it's drawn the picture for me, which is nice. The only thing that isn't quite so nice is when it labels the picture, it does throw in these nice, pretty even numbers instead of counting by standard deviations. So that really is the only drawback. But if you want a quick visual, the calculator suite probability does the calculation rather, and shows you the picture, which is nice. And it also does left tail, right tail, and outer tails instead of middle tails. All right, if you have any questions on what you saw in this video, feel free to send me an email or drop by office hours. Otherwise, I will see you in our next video.